Hello, this is Greg Allison from Bring Greg's Garden and Worm Farm, coming to you today on the 8th of July, 2020, with a special guest, Dr. Arthur Bradley. And Dr. Arthur Bradley has a PhD in electrical engineering. The man has specialized for some time in protecting home, electronic devices, automobiles, and various things from EMP, high energy waveforms. He is a dean of protecting what you have. He also is a prepper and covers other prepper topics. He has his own YouTube channel. I'll share the link below. And he sells things to help you protect and harden your devices. So Dr. Bradley is an excellent go-to source for things to keep you safer when things get rough. So Dr. Bradley, tell us about yourself.
Sure. Well, thanks for the nice introduction. Well, so as you know, Greg, my day job is at NASA. I work at NASA Langley Research Center. I'm a branch head of electronics branch. My night job is where it gets more interesting. I write books on the side. I've written, I guess, about 16 books or so.
Yeah.
Run the website disasterprepare.com, and just all around I'm into sort of family preparedness with a special emphasis on EMP preparedness. Been in this preparedness world for probably the last, I don't know, 15 years or so, I guess.
Yeah, and what a lot of people don't know is that you also attended my Power Grid Defense Conference.
Yes, I did.
We had you as a speaker there because you cover shielding your home and devices from electromagnetic pulse and other prepping topics. You really covered both sides of that, which I think that is of great interest to my channel. So for my viewers, I might want to add, this will probably be, kept to within pretty close to an hour today, because Dr. Bradley has somewhere else he's got to go early in the morning. He's got some things he has to take care of. And because he covers such a broad breadth of area, I hope we can have him back many times in the future to cover many of these different things individually and some of the other topics and things coming up. He's also got his own YouTube channel and website. I'll put links to those below too, so that you can see what he has. And go subscribe to his channel, for Pete's sake. And oh, by the way, when you're thinking of subscribing, subscribe to my channel if you're not already subscribed, because you'll get the update notifications for things like this. But you also got to bang the update notification bell, bang the bell, and click all when that comes up for the free selections. But you still need to come back occasionally and make sure you're actually getting the notifications and don't get unsubscribed, which sometimes the algorithms like to do to topics that are not covering things like pop culture and kitty cats. When you cover topics that might mean something, it scares them. So all that said, what I want to get into is how you protect your home, your auto, and your personal electronics. Now, this will be probably a thumbnail sketch within the hour we're given. One of the things Dr. Bradley has covered is a Siemens FS140 and some ferrite beads that he puts in on the input power of his breaker box. So tell us what you do for your home. What's the best way to protect the home?
Sure. Yeah. So, the EMP is a complicated threat, right? And we can talk about that. And so the solution to it is a multifaceted sort of problem. And so it's difficult to sum it all up as, you just do this and it's all protected. But
there is no one thing you can do. Contrary to a lot of things that are being promoted today, there is no single thing you can do to protect the home.
Yeah. So the way I look at it is there's two significant areas of threat. The first one is the conducted energy that's going to come in on your lines, right? Your power lines. And then the second one is the radiated energy that's going to propagate through space and come down into your house and your house wires and everything else. So let's talk about the conducted pulse first. I do think the conducted pulse on the power lines is the most dangerous threat. And that's because it has a nice, easy path to come in your home, right? The energy couples very well onto long conductors like that, and then it ends up coming in your home. So what you want to do is you want to try and reduce that level that the appliances and the electronics in your home are going to see, right? And so I came up with sort of a three-stage strategy really to that. One of them is you want to install a really high quality surge protector at your breaker panel, right? And I don't care which one you install. I don't sell surge protectors, but I looked at, I guess, about a dozen. I took them all apart, studied all the parts in them. And the one I liked the best was the Siemens FS140. Again, I don't sell it. You can find it on Amazon. You can find it wherever you want. About $180 or so. I have one on my house. And they're easy to put on. You wire them into a double pole breaker. It's not a big deal to put them on. And the idea of them is they can take up to about 140,000 amps but very, very briefly, right? Only for microseconds of time.
Is
And
it
so the question,
nanoseconds or microseconds? What is the real?
microseconds.
They'll take
It's
microseconds.
microseconds. They can take them for microseconds. They'll be destroyed if they take that kind of current. No doubt about it. The MOVs, the varistors that are in it will overheat. They'll blow up.
Yeah.
I've blown up a bunch, right? Because I wanted to see what happens,
Some
right?
people
And
say their devices will survive this 42 times.
yeah, well, so in my experience, right, you drive them for a long enough period of time, it doesn't take long, they end up exploding. But so you put this high quality surge protector on there, and the goal of that is really to shunt the energy from E2. That's its primary goal. So EMP has an E1 event, really fast nanosecond type event, an E2 event, which is in the microsecond range, and then an E3 event, which can last for seconds or even longer, right?
Okay, let's talk about that so
Yeah.
that everybody knows. E1 is your shorter wave waveform that comes directly through the atmosphere from the after the gamma rays push the electrons out, and it comes in three forms: E1, E2, and E3. The E1 is the short wave stuff that shorter circuits will pick up, like maybe some of your devices, not necessarily all of them. A cell phone might be too small to pick it up. Your car might survive it, but the circuits in your house could potentially really pick this up, and it could be a huge problem. The E2 is like lightning. And now your surge protectors are typically designed for lightning, and you should be good for an E2, unless you get hit by the E1 first, which is what's going to happen, and it weakens your system. And then the E2 might then be a problem if you've blown your circuit protection out. And then the E3 is the long wave stuff that's picked up on the power lines, the rail lines, the pipelines. So it comes in your power lines. It's the long wave stuff. The longer conductors pick it up. And that's the same thing you get with the sun. But now the E3 can last tens to hundreds of seconds. And that can really fry things. So go ahead.
Right. Yeah, so you're right about everything you said is right. And so we start by addressing the E2 with a quality surge protector. Again, I like that Siemens model, but if you like another one, pick a different one. All type 2 surge protectors that are UL rated have the same sticker on the side of them that tell their ratings. And so you can compare two surge protectors very quickly, very easily. So I don't put a lot of credence, by the way, in surge protectors that specify a turn-on time, because there is no standard for how you measure turn-on time. So I just tell people be cautious about using that as a metric. But so anyway, you put your surge protector on there, and as you said, the surge protector has some things it will do well and some things it won't do well. And so what I do is I supplement those with some ferrites around the input power mains, right? And
right. So
now
that's your first. That's actually your first defense in this case, is your ferrites, because that's where the power comes in.
Right. And the idea of the ferrites is they by themselves are not going to sink energy away. What they're going to do is they're going to limit the time rate of change of the current, right? And
like a choke,
so,
like a
choke.
It's
exactly right. Exactly right. And
so it produces a back EMF. It's resistive. It's reactive.
That's right. That's exactly right. And so these ferrites, in theory, when you get that E1 pulse that comes in, it tries to change the current level very, very fast. And the ferrites, their whole job is to spread that thing out in time a little bit. So instead of it going up in 3 nanoseconds, maybe it takes 12 nanoseconds to come up, right? But that's enough time, roughly the amount of time a MOV would need to turn on. And so that quality surge protector that you put on there hopefully kicks on and starts shunning away the E1 energy, and then E2 comes in, it shunts that energy away. Again, all that's by the time is microseconds. And that's how you kind of deal with the E1, E2, is with the ferrites combined with the surge protector.
Okay, so
now,
let's define this a little bit further. What the surge protector itself does is it senses the current, and then it shunts it to either the ground wire or back into the neutral. I don't know.
It actually senses the voltage, but yeah, it gets to a certain turn on voltage, and then it does basically a dead short to the line or to the ground. Yep. So either from line to neutral, line to ground. Yeah.
And that's only as good as that cut conductor can withstand going to the ground. And you know, if E3 might be a real problem in the tens or hundreds of seconds, none of these conductors will stand up to that.
Correct. That is absolutely right. So E3 is the hardest part of it. The last thing I'll make a point about the E1 is that if you just go out and buy some ferrites, and you can buy all kinds of ferrites, and you clip them around your wire, the problem with it, the reason they don't normally sell ferrites for these high current feeds is the ferrites will saturate. Basically, if you put too much current, even just DC current or AC current, the ferrites essentially become saturated, and they don't dampen those current surges anymore. And so they just don't do anything. You put them on, they just don't do anything. So what you have to do is you have to modify the ferrites by introducing a very, very small gap in the ferrous material. That's how they're modified. Yeah, and so the ones that I sell, the whole house ferrites, have a very precisely controlled gap introduced in the ferrous material. And that's actually what keeps them out of saturation. You have to run all the calculations based on, what gap length you need, what the material is, all that stuff, right? But anyway, that way you can actually get some benefit from the ferrites. If you don't do that, your ferrites actually won't do much for you. So that's kind of E1, E2 was with handling with ferrites at the power feed, putting in a quality surge protector. And the other thing I don't mention all the time, but it's worth noting, is having small broadband ferrites out at the devices is also very important. So if you have, let's say, a very sensitive computer, it's nice to have a broadband ferrite at that computer or very close to it. Because, of course, some energy is going to couple into the house wires anyway, right? And some will come through, and it's nice to have something to try and help suppress it right at the device as well. So that's kind of E1, E2 is through the use of ferrites in a surge protection device.
Yeah. So, yeah, I was looking for a pen. I was wanting to mark on my whiteboard, but I got an online diagram I can pull up. What a lot of people who are not electrical engineers, such as you and I, of course, you're the PhD in it. I got a bachelor's degree in electrical engineering. That's why we both work at NASA.
Yeah, we both work at NASA.
Different field centers. You're at Langley, and I'm at Marshall.
Yep.
So, but you're actually NASA, and I'm a contractor, so that makes a big difference too. I'm one of the things you guys use. We're dispensable. But anyway, all that said, what a lot of people that aren't inside electrical engineering don't understand is something called current division, and there's current division and voltage division in a circuit. So if you've got you got a line coming in, you got various branches going out, not to ground. Of course, the ground is the lowest resistance. Most of your current will shed to a ground right off, but some of it's still going to go down to more resistive paths. So some of this current, even with a surge protector, is still going to go into your house. Now, hopefully, your circuit breakers will trip and save you from this, but there's a time element in that, so stuff can still get in and fry things inside your house, especially if sensitive electronics like your computers, your TV, and one day all our components and appliances are supposed to be smart, so they may all be susceptible.
Yeah, it's possible.
How smart is that, really?
Yeah. But, yeah, the current division thing with the E3 is a good point, right? That even if you shun it away with an MOV, you can only do it for a very brief period of time, right? Because the E3, as you said, can last a very long time, and varistors are only going to survive, let's be really generous and say handfuls of milliseconds, right? So not long. They won't survive long. And even if they did, the wires, as you said, would burn up. I mean, there's a lot of issues on time. So what you want is just what you said, is you want to dump as much energy as you can down through that surge protector as fast as you can, which is why you put the surge protector very close to the panel and all those things, right? And if you're lucky and it all goes your way, you dump enough current to trip the breaker on your home. You pull it. And if that happens, the home's disconnected from the conductive pulse. The rest of E3 doesn't come in, which is beautiful. Now, I did some tests. I wanted to find out, well, is that even possible? Can you trip a breaker, a 200 amp breaker through one of these things? And to do it, if you just look at the breaker trip curves, you have to pull between 10 and 20 times the rated current to trip it in what's called the magnetic region. They're thermal magnetic breakers now, right? And so there's a magnetic region. If you pull a lot of current over the breaker rating, it goes in a magnetic trip. If you pull just a little bit more, it goes in a thermal trip, and it might take many seconds to trip.
That's too slow.
Too slow. So you have to pull a bunch, and you have to pull, let's say a 200 amp breaker, you have to pull, let's call it 4,000 amps.
Well, the RPCs on our spacecraft, the remote power controllers that we use, trip the same way. You got a fast trip and a slow trip the same way.
They sure do. They sure do. So you want to get in that fast trip mode, and if you can do it right, and you've got a thermomagnetic breaker, I did verify on my home, and it was an experiment my wife did not enjoy. I can't pull 4,000 amps safely, but I could pull more than 500 amps safely. Wow. And I was able to throw 50 amp breakers with surge protectors and verify that, yep, if I got an overvoltage condition, that surge protector would pull it and trip that breaker. Now, it would blow the surge protector, make no doubt about it. The MOV would explode in quite a flash. But it did convince me that thermal magnetic breakers could be popped pretty quickly by pulling, you know, a few thousand amps through them. And so I think there's a possibility that a good quality surge protector could do it, but there's no guarantee. It's definitely not a guarantee. Yeah, no
Now,
guarantee.
here's what I was trained when I was in the military. You know, in the military, we had to have a posture so that we could survive a nuclear strike and be able to get up and run again, provided it didn't hit us directly, of course. You know, if we're vaporized, you know, we're out of the game.
Yeah.
But, you know, a little radiation, you ought to be around for a while before you drop over, right?
Yeah.
Still get out and shoot the rifle a few times or communicate. And you know, I had a ANTRC 138, which was a microwave communications van hauled around and back to a deuce and a half. Now, I got this one when I was actually in the Guard afterwards in the Army, but I initially got this training in the Army. I was in the signaling unit before I went to Alaska. And they taught us that an EMP is so strong, so powerful, that you actually have to have a complete radio set, completely disconnected, all the cables put up, the boxes have got to be completely shut up, the ports have got to be closed on it. Anything get in there and will fry that radio. And they said you couldn't even have a throw, like going into our van where our power thing, we had one of those old throw switches that, oh yeah, and I tell you one thing, I had a guy set the generator on 230 when it's supposed to be in 110, and I was sitting there on that thing and couldn't switch it fast enough. My trailer, my thing burnt, and you know I wanted to clobber him because he didn't turn the generator switch it right, and he's supposed to check it, and he didn't. I was just sitting there waiting, and I tried, and just as soon as he flipped it, I mean I smelt it instantly. I flipped it. It was too late. Every wire in that man shelter was toast.
Right.
But
yeah,
anyway,
and radios especially are very susceptible because they're of course meant to pick up small signals, right? So you're right. Anything that's
the wired harnesses, maybe it's fried everything. You know what burned plastic insulation smells like?
yeah. If you put twice the rated voltage on it, there's a lot of current going to flow, right?
Yeah, it's just two times.
Yeah.
So yeah, we know about derating wire. You and I, and you know, I used to design the industrial parts washing machines for a little over a year. And, you know, I had wires this big around that were pulling 400 amps, you know, for running a 75 kW dryer, electric dryer.
Sure.
That's a lot of current. But all that said, the thing about this is that what they taught us was that even if you had a big double pole single throw switch like that with the two conductors, you know, way apart, that arc, because the high voltage potential, you get dielectric breakdown in the air, it would jump the gap. There was no switch that would protect you. That's what they taught us. They taught us that, and what I have seen, I've seen, you know, like the big transformers and the big power stations, when they open their switches, you know, those things, they got these switches open in the air, and it's like a lever.
Draw the arc.
It pulls back several feet, and you can watch an electric arc shoot through the air like 30 feet.
Sure. Yeah, and that's why it's real important that the E1, E2 pulse be shunted away, because you're not going to break the line during those.
Break it. You got to put it straight to the ground as fast as you can.
Right.
But
E3 may only be, maybe only be hundreds of volts, right? Maybe let's say 400 or 500 volts on the lines for E3. So it's possible to open that one, but yeah, you wouldn't try and open the E2, for example. Just be too high.
Yeah, the E2 is going to be such a fast pulse. But the thing I worry about is still, even though you might trip that breaker in the house, you can still get current into the house. And that's like
you can through the air, sure.
Yeah, so much going to be going to the ground unless you burn that conductor out, which you'll probably do with the E3. So at that point, you might have it surge over. It depends on what the voltage is. But what we know now, in 2008, Dr. William Graham, he's a physicist, and his PhD in electrical engineering, as you do. He was at one time, you may recall, deputy administrator for NASA, and became an acting administrator for a period, a little over, somewhere around a year. But his main thing was he was a Soviet weapons expert, and he's actually considered the nation's foremost expert on EMP. He was told when the Soviet Union fell, you know, he was active during the Reagan administration and after. He was told after the Soviet Union fell that by Russian generals, that they had EMP super weapons that could put out, and this is congressional record. It was in congressional record 2008, so this is not classified anymore. It used to be. But they could put out 200,000 volts per meter on the lines. The hardening standard was something on the order of 50,000 volts per meter. But the thing is that your typical nuclear device, because of the casings, the shielding, and even in a hydrogen bomb, the actually the plutonium fission bomb actually shields a lot of the gamma rays. Only like 5% of the gamma rays get out of those devices. And so what they do is they maximize these devices to emit gamma rays. It has less shield and less material, and so it's purely a gamma ray machine. And it's just stupendous to think about what they can do. They claim that at the end of the edge of the field, it'd be 50,000, and that's right at our heart. So what we were saying before, if you go back to those 1975 charts that you see on Wikipedia and other places about EMP, they show you things like 20, 30,000 volts per meter. And if that's all you got, the hardened, at least the more hardened places would be good. Of course, most of our stuff is not even to that level. So we're really susceptible. Now, what that means is you can get a tremendous surge on our power lines, and it would burn the power lines. So maybe your saving grace is the power lines are burning going to your home, but you got to worry about that E1 getting picked up in your circuits inside the house. And no device on your circuit breaker box is going to protect you from that. So what we're talking about is a level of protection which beats the heck out of nothing. I mean, it's helpful. Personally, I think the best thing to do is get off the grid.
Well, yeah, sure, if you can.
But even
then, you can address the E1 of smaller appliances and smaller devices differently, right? You can have small EMP bags or Faraday cages to put really susceptible small devices in, and that's one of my recommendations as well. Because you're right, you can't completely protect from E1 at the house, at the box level. Yeah,
we won't talk about autos and smaller devices, but you can do things. Hey, their weapon may not work perfect. You might be at the edge of the field or one of the places where it all depends on the shape of the magnetosphere at the time.
Whether you got a mountain nearby or whatever else.
There's a lot of different effects. So, it may help. It may keep your house from burning down. I mean, I think the primary objective is not to have your house burned down. That's what I worry about. Your telegraph stations caught on fire from the E3 of the Keratin event back in the 1860s. So a lot of people just don't really appreciate what this can do. So that said, these levels, what Dr. Bradley's talking about here, will help you. It's worth doing. But he's not talking about one device. Let me share something. I'm going to show something here. Give me a second. I'm going to share a website here if I can find it. Pull up. That's not the page I want to find. Practical tips. This is a website talking about how to install surge protectors. And they're showing here the different stages to use. And this goes by really current division here. They're showing you your direct shunt to the ground, carrying maybe 80% in this case, and having another shunt and having something at your device itself. And if you read the instructions here, so this gives the picture. No one device by itself is sufficient. Of course, you're using the Ferris devices on your input lines as your first device, and that would definitely be very helpful. It's a good idea. Some people tell you their little device is going to cover everything. But what these directions says, and this is the electrical engineering portal. So this is electrical engineering website here. It says a combination of surge protected devices in order to limit overvoltage as much as possible. A surge protection device must always be installed close to the equipment. And then it says, however, this protection only protects equipment that is directly connected to it, but above all, its low energy capacity does not allow all energy to be discharged. And that's what they show down here. And anybody that's ever done circuits, Kirchhoff's laws and so forth, as you and I know, knows that you get voltage division, you get current division until you open the circuit, and then hopefully, you don't get dielectric breakdown of the air and get a spark gap and things jumping across. But this is a depiction of what we were talking about here on this website, and they're showing a lot of the circuits, how to install them, different things like that. And I've got another little website I pulled up here.
Yeah, and that shows the idea I was talking about, where you want to protect as far away as you can first, right at the entrance to the home, and then if possible, you want to protect as close to the devices, as you can as well.
Right. And here we see this how to put in the device like the Siemens FS140 or whatever other device.
Yeah, that's the Leviton.
So I take it. Here you got your shunts to neutral or ground.
Yep.
What are we doing here on the 20 amps? Would you explain that, or is this the sensing circuit here?
So those are so you tie them to two different, one of those breakers ties to line 1 and one of those breakers ties to line 2. The way the modern breaker panels are done, they're interleaved as they run down on one side. And so basically, whether the surge comes in on line 1, line 2, or both of them, there's a path through those breakers down through either to ground or to neutral. They're all connected in the surge protection device if you have a good
So
quality.
this is on the input side of the breaker.
Yeah. Mm-hmm.
What I thought.
Well, no, it comes in through the main, right? And then it goes out through the 20 amp breaker into the surge protection device and shunts away. And so this is essentially the sense points where if those voltages get too high, it turns on the surge protector and shunts away.
That's what I thought. That is the sense device right there.
Yeah. Okay. And sometimes what people will do is they'll connect really critical loads to those 20 amp breakers. I do that. And so let's say you can't pull the main breaker on the house. You just aren't, it doesn't happen.
Yeah.
At least you will pull those two breakers. I guarantee you'll pull those two. And if those circuits that you had tied to L1, L2 were really, really critical, maybe they're the things you can't live without, at least you'll know you'll open the lines to feeding those devices.
Yeah. Here's your Siemens FS140 data sheet. It don't really make any claims as to what it can do.
Well, the claims are on the side of the box, but they're not related to EMP, I can tell you that.
Right. It's an E2 device. It's for lightning.
Yeah, it's for nearby lightning.
You find this to be as good as anything else, if not better.
It's the best I found on the market. Period.
Okay, so for everybody's information, this is what we would call top shelf.
Yeah, I think so.
I'll stop the share here. Go back to our screen. I just thought it'd be interesting to pull that up. It's kind of
that's great.
I'm an electrical engineer. You and I know what voltage division and current division in this case is, but a lot of people wouldn't understand that.
Sure.
I was reaching for a marker a minute ago. I wanted to draw it on my whiteboard, but I couldn't find my marker fast enough.
Yeah.
So
And I will say again, if somebody already has a surge protector that they really like, that's fine too. I don't have any stock in Siemens. It's just one that I really like. So there's a lot of other good ones too.
Yeah. And I know you have gone through them and looked at all the components themselves in many of these devices. You know what they're made out of.
Mm-hmm.
So again, these will provide you a level of protection.
Correct.
They're not all encompassing. None of these devices cover everything.
Right. Well, we've never had an EMP hit in the United States, so we don't know exactly what's required to survive it, right? We're doing the best we can.
And it depends on who hits us and what they hit us with. There's a lot of unknowns. But the idea that one little box with some little speaker wires coming out, it's going to save you from everything is a little bit optimistic. Just a tad optimistic. But, hey, it beats a poke in the eye.
Sure it does. Sure it does.
All right. So some people think those things are going to cover the whole power grid. Far from it. Far from it. What we're trying to do here is keep your house from burning down. I've had some people ask me, well, what's the purpose of doing all this EMP protection if there's no grid to give you power? Well, you need to have some way to generate your own power to recharge your batteries so you can use your radios and other devices until that day comes if every device you got wears out.
Yeah.
To give you an advantage for a while.
I give them two answers to that because it's probably the best question people ask, which is, well, if the grid goes down, why do I care, right? And the short answer is just what you said. Well, the grid may go down, but I may want to roll my generator out and hook it to my house, or I may want my solar panels to provide some power. And it's nice to have a functioning house should that happen. The other thing is that the grid may not go down and stay down all the time. It may go down and come up for 30 minutes and go down for another 2 hours and go up for 15. It may be such that they bring it up and down. There may be ability to bring parts of it up and down. And you'd want to be positioned to take advantage of that. You'd want to have a functional household if you could.
It depends on what kind of event you have.
Correct.
It really does. If you had a military attack upon us, if we had a solar Carrington event, then if it fries all those big high voltage transformers,
you're in trouble then. Yeah.
We're done.
Yeah. Yeah.
All right. So let's talk about protecting. We just talked about devices. Take your pick. You want to talk about protecting your vehicles or your personal devices first? You lead.
How about personal devices, since it sort of lends to the same topic there. And it's fairly easy actually to protect small devices. Let's say you want to protect a laptop computer or something like that, right? All you really need is some kind of shielded enclosure that can provide about 50 dB of shielding or more. Some people say more than 50, but if you run the numbers, a 50 dB will probably survive anything. And you can get those cheap. You can buy these little anti-static EMP bags, what people call them. And they're a few bucks a piece, and you can stick it in there and tape it up. And I've verified the shielding levels of those in my laboratory. They do quite well. all
You have
across.
videos. You have videos.
I have videos, yep, where I test them.
I've
And
got
I
my
tested a
phone,
number of,
so it won't ring
yeah.
while we're in there in a little bag of
So
stuff.
those provide about 80 dB of shielding. Those cell phone pouches, yeah, they're really good. I actually have some similar ones, not they're sort of smaller, meant to be used for anti-tracking, but they do provide about 80 dB of shielding, pretty slick.
Oh yeah, you did videos about COVID tracking.
Yep.
And ladies and gentlemen, he's also got videos about cleaning and sanitizing your N95 masks. So you really want to check out Dr. Bradley's YouTube channel. Subscribe. Do it now.
Yeah, so protecting small devices is probably the most straightforward thing. Put an enclosure, some kind of conductive enclosure around the item. Now, one thing that's an interesting experiment, I often ask people this, and like they'll do the garbage can experiment, right? They'll get a metal galvanized garbage can and they'll put their stuff inside. So let me answer a couple things right off the bat. One, you don't need to ground the garbage can. People have big arguments about that, but you don't. It's a shielded enclosure, it's Faraday cage. The second is, if you want to line the garbage can with something non-conductive, fine. That doesn't hurt anything, like cardboard or something. But most things that you put in there already have plastic housings on them. They're already non-conductive. So if that's the case, you don't necessarily have to line them. That's the first two things I always get asked. The other thing is, it's not the little holes in the garbage can that cause you trouble. Like people worry about the little holes around the handle and things like that. It's not those that get you in trouble. It's the seam around the lid that gets you into trouble, okay? So if you want to turn your attention to really hardening the can, you have to seal up the seam of the can, the lid of the can.
Right.
And yeah, I sell some, go ahead, Greg.
Keep talking, I'll be right back.
Oh, all right. So I sell some gaskets that I measured that do a great job of sealing up those cans, but you can also use conductive tape if you'd rather just tape them up. But the key is to get those long, narrow seams, taped up where they have a conductive barrier on them. That's really the trick to it. And if you do that, you can get about 70 dB or better out of a garbage can or anything like that. Yeah, there's some conductive tape right there.
I got a roll right here of this conductive tape that I got at probably at Lowe's or someplace like that.
Yep.
So it's aluminum tape. It's got a cloth back in here so it won't stick to itself. And you could wrap this around the outside seam. Some people like to just line it around the can on the lid and around the outside edge just to make it tighter. That is not as good as putting it around. If you need to get in and out of it a lot, that would work.
Yeah. Yeah, and that's what the gaskets do really nice is you put a little gasket on the inside of the lid and it just slides on and off and seals it tight. But that works fine and it's cheaper. The tape is cheaper. The only negative of the tape I found is it's a hassle to pull on and off and you can cut your fingers up on it. But it is cheaper and it works fine.
But it will wear out too.
Yeah, it will. It's an interesting experiment. If you build up a really good Faraday cage like a garbage can one or something, and then you take an electric drill and you put, let's say, an 1/8-inch drill bit on it, and you ask people, what's going to happen if I start drilling holes in the side of my Faraday cage can here? How's the shielding going to deteriorate? Is it going to go down really bad? Is it not? And most everybody will tell you, oh, if you drill some holes in it, the level of shielding will drop appreciably. And that's actually not true because those holes are very, very small and they don't act as very efficient antennas. So you can actually build up a Faraday cage, you got 70 dB of shielding, then you just start drilling holes around the outside and that 70 dB will maybe go to 69, 68. It's very small degradation. But as soon as you take an X-Acto knife and you cut a slot in it, that 70 dB will drop down to 20 dB. It's really significant. The slot antenna effect is very significant. So it's something to keep in mind.
It's wavelength. It's got to do with wavelength.
Yes, it does. The maximum diameter of that has to match up with the wavelength of the signal. Yeah.
That's why on a microwave oven, on the front glass, you got a little screen with a lot of little holes. Those holes are smaller than the wavelength of the microwave, so the microwave can't get through. The microwave, it's a solid object. We can see through it. Visible light gets through, but microwave is longer wavelength than visible light. Kind of like 5G is longer wavelength. A lot of people don't get that. So, because it's also radio, RF. In any event, so when you understand electrical engineering and antennas and stuff like that, these things start making sense to you. And hopefully we'll get people up to speed on some of these things.
Yeah.
That's a cool thing to know, and people need to understand. And you're bingo, you're exactly right.
Yeah.
That's why some antennas are mesh too, because that mesh is the holes or the gaps in it is smaller. Look, they used to use chicken wire. I remember when Von Braun went to India, he had people building satellite antennas with chicken wire. For the lower frequency signals that we're using now. I forget which band we're using. But
Yep. So anyway, that's some takeaway tips maybe as people build up these Faraday cages and stuff.
yeah, and I got a video on my channel that I did with a guy called the Tennessee Prepper, and he had a cage like a Faraday cage like that, and we were putting the things in them and playing around with it. So I've got a video on my channel about that people can look at, and you got tons of videos. People really need to see your videos because yours are far more precise because you've got your home laboratory with all the instrumentation to check these things out. One of our guys in my rocket group used to have quite a lab like that with all kind of stuff in. We developed our own avionics, but that wasn't my house. It was, you know, we had a rocket workshop and we had a workshop for burning our avionics. And talking about the time factor, you know, the time factor it takes to burn things up. We do the same thing with like if you're doing a ablative nozzle on a rocket, it's good for a certain amount of time, but once you get beyond a certain thermal soak, all components, you know, can go. But rocket engines typically run for just a few minutes. So if you can build a device that can handle the heat for a few minutes through ablation or whatever other technique you've got, then you survive. But thermal soak will tear up anything just about if you let it get too hot. And then same way with temperature, with you know, that's what's happening with your current. You're getting things hot real fast.
Sure.
I have vaporized wire. We were using nichrome wire to cut styrofoam to make a big peanut for a launcher for a balloon, because we needed a huge surface area to hold the balloon down. And so we were cutting the styrofoam. We used a nichrome wire, and we had a resistor so that we wouldn't put too much current through it. It had to be a fairly high voltage. But I actually bumped it one day. I actually hit it accidentally, and that wire was just like a flash bulb. It was poof. It went straight to gas. It went from solid to gas instant with a bright flash of light.
You turned it into a fuse. Yep.
Bingo. So yeah, we know what this looks like. This is what a wire can do, and even a bigger wire with enough current will do just that.
Sure will. Yes, it will.
And that's what a lot of people don't know and realize is you can actually vaporize. And I'm not talking melting. We're talking vaporizing. Any size conductor with sufficient voltage and current. And we could have that happen in our power lines with it. If you had a EMP super weapon, it would be a little too interesting. So anything you want to add on the personal device level?
No, I just think there's a number of ways people can tackle that problem. Everything, like I said, from the EMP bags, which are inexpensive to do, to these homemade ad hoc Faraday cages are fine. You can go, you can spend as much money as you want, and probably the more money you spend, the more convenient it is. Maybe a little bit works a little bit better. But my recommendation to most folks is usually some EMP bags if you're just protecting small stuff works really well.
Okay. So another thing is a lot of your small devices they could be fried, but it's not a given that they will be.
Right, because the length of the conductors are relatively small, and so they don't couple a lot of energy into them now.
Now, an automobile might be more susceptible, but a lot of automobiles will survive the EMP. And especially your older ones. I got a 76 Chevrolet truck out here. I think it'll probably be just fine. But, but even my other vehicles might be okay.
Yeah, the verdict is out on automobiles in my mind. They did some testing, and the EMP Commission did, but the testing was not complete. And a lot of people fault the testing the way it was done because they didn't want to damage a bunch of cars and be responsible for all that expense, is my understanding. And so the verdict, I'd say, is still out on how susceptible cars are. But the difficulty with cars is, they're these hugely complex things now, right? They have hundreds of cable assemblies on them, and maybe hundreds, if not thousands, of processors and microcontrollers all over them. So there's just a lot of things that can go wrong, right? There's a lot of places energy can couple into and then start causing damage. So they're very complex and they're very susceptible in that sense, but they're also usually not energized, right? When the car is sitting in the driveway, it's not energized. You have to bring up the energy level enough to exceed the maximum values of those parts. And so that's sort of the conundrum is, can you bring in that amount of energy for enough time to damage those parts or not? And like I say, I think the verdict is still out, and it's a difficult problem to solve. It's very difficult to protect an automobile.
Yeah, well, and a car is not a good Faraday cage, but a lot of cars have, a metal chassis, a metal, your engine compartment, your dash. Not all cars, but a lot of them have a lot of metal to them. A lot of these components are protected by that or the frame itself. It's sitting on rubber tires, so it's insulated, at least from the ground. So there's potential there, but then again, it's not a given. You definitely could lose a lot of cars on the highway. The problem be, even if just a few cars go out, the whole highway will be blocked up. Your interstates, you're not going anywhere. It'll be just a roadblock. So if you got to travel after an EMP, take the back roads.
No, yeah, right.
You may
Yeah, I
not
mean, if you
have,
think about it, even if you had, let's say, 5%, let's be kind and say 5% of the cars are going to experience enough damage that they end up shutting down on the highways. Imagine 1 out of every 20 cars on the highway suddenly losing power, right? I mean, I can't even imagine the kind of chaos and damage you'd have. So,
well, your house will have a lot of wrecks too.
yeah,
So it might be like 2 times the cars.
might be. Yeah, might.
And you get pile ups and things like that. Yeah, it would not be a pretty picture though. I would not want to be on the interstate, but so you might need to learn your area and learn how to get around without your GPS in case your personal device gets fried. And our satellite network may be somewhat less than it is today. And the processing centers that run all that software to keep all that coordinated, all that may be gone. So you may not have GPS at all. It's good to have a map with you, and it's also good to know your area. So don't be totally reliant on that GPS, or you might be suffering.
Yeah. The one experiment my family conducted, I got some pictures in my EMP book, was we wondered if you could protect the car by covering it with a conductive cover, right?
Yeah,
Because
yeah, I've seen
it's
it.
sitting in your driveway, right? And you don't want to lose your vehicle. And again, there's no guarantee it's going to go out, but if you don't want to lose it, what could you do? And we came up with, well, you could cover the whole thing, basically make a big Faraday cage around it, right?
Right.
And we did it the first time with, we put plastic sheeting over the car and then aluminum foil over the whole thing. We got pictures in my book of doing it. Neighbors thought I was nuts, I'll tell you that. But it ends up doing a pretty good job. You get a little better than 20 dB of shielding inside the car, which is 90% or so of the voltage knocked down, electric field is knocked down. And that's probably enough, frankly. I can't imagine that modern cars be damaged by 1/10 of the level that it would normally see from an EMP. So I think that's probably a way to do it. It's not cheap though. Nobody I know of makes conductive car covers, at least not I'm aware of. I sell some conductive cloth. I tested a bunch of cloth out and found one that I thought would work well as a cover, but it is incredibly expensive for anyone to buy.
How much would it
So a car
cost?
cover,
How much
what's
would it
that?
cost for a car? Average
A
car.
car might cost you anywhere from $1,400 for a little one to $2,500 for one over an SUV. I mean, the cloth is just incredibly expensive.
Yeah.
And so now, don't get me wrong, people have bought some,
Oh yeah.
but you really have to be serious. You really have to think, okay, I can't lose my car. I'm willing to cover it with conductive cloth anytime I'm not here, anytime I'm not using it, or anytime I think a threat is perhaps coming my way, I'm willing to go out and do that. And I think it would indeed guarantee the survivability of your car, but again, it's a lot of money to invest in something, and I recognize that.
All right. So now we've covered protecting your home. We've covered protecting your personal devices, and we've covered your automobile. Boat might be hard to cover with a cloth.
Yeah, yeah. Cloth is usually for people do it for cars and for generators. A lot of people cover their generators.
What would be the most susceptible part of a generator? The ignition system?
I would guess, unless it's one of these modern generators that have all that digital stuff on them, those would be susceptible. But I had an old Briggs and Stratton that, was one of the pull handle crank kind of things. I don't believe an EMP would have bothered that at all. But some of the more sophisticated ignition systems and stuff now, yeah, maybe it could be damaged.
What about the Generac big propane generators?
Yeah, I think it's possible because they have long buried conductors and long, of course, electrical conductors to them as well. So it's certainly possible they could be damaged. Again, though, they're pretty robust. If I had to place a bet, I would bet it would survive. But you'd want to definitely have a surge protector where it connected into the home. That'd be the number one preparation. You could look at ferrites and you could look at covers as well. But
probably on the generator itself too. At least
yeah,
ferrites on it and at the house.
Yep. And ferrites are pretty cheap.
Protect it and your home.
Yep.
What would you advise people about E1 radiation inside their home?
Yeah, so you're not going to get rid of that, right? You're not going to shield your whole house. And so E1.
Well, now I got a friend, Curtis Stone, who is the urban farmer up in British Columbia. He painted his entire house black with this conductive paint.
Really?
And he
that's expensive.
He put shades over his windows with a screen wire and stuff.
Yep.
So you won't get a cell phone signal inside his house.
Right. It can be done. I actually evaluate conductive paints. They work pretty well, but it's really expensive and a lot of work to do that, obviously. So normally most people have to live with it. They want to have service in their house anyway. Most people want to have, their self-service and stuff. And so what you really have to do is figure out, well, all right, if E1 comes in, what can I do to mitigate the effects of it? And the way you do that is you typically put the really sensitive stuff in EMP bags or Faraday cages, and you put ferrites at the devices that have to be plugged in. Unplug anything that you absolutely don't need to be plugged in, and that helps as well.
And it also helps to pay attention to what's going on in the world. If you suddenly know that we are on the verge of a major conflict, you might want to take extra precautions in disconnecting things. So I do a lot of videos, and I call them "Keep Your Eyes Wide Open and Head on a Swivel" news, because that's what you need to do. And a lot of the the news service don't tell you anything except the politics in Washington D.C. and trivial junk. They don't tell you what's going on in the world or things that the people really need to know. So I try to cover as much of that as I can. But the world is so active right now. There is just so many things happening. I mean, right now we have carrier groups in the South China Sea, and China is somewhat less than absolutely pleased.
No, I bet they aren't happy.
So, there are lots of prospects right now for things to go bad. So people need to be very, very aware. I probably should do a video on that, but I've done so many on the CCP and China of late that it may be too much. But that's where things are happening. That's a 900-pound gorilla in the room. And bear in mind, I'm never picking on the people anywhere. There's good people in every country, of every faith, religion, and creed. There's good people that are smart, that are studious, that have a really good heart. It's usually the leadership you've got to watch, because we got this old saying, it flows. And we know that sociopaths and psychopaths have a hunger for power, and they usually climb the ladder and all too often find their way to the top. Especially in tyrannical type governments, you almost have to be that personality type to be in charge, and that's scary. That's why I hope more and more countries can have more democratic forms of governments that provide checks and balances and freedom of speech and ways to file redress and grievance against that government. You can't do that in China. In fact, I've just been told that China is in the process. Maybe you told me that. I think you told me that.
Yes, I did. Yeah. My wife was telling me that. I haven't researched this, but I suspect it's true. She keeps up on things. Was that China was either passing a law or attempting to pass some kind of law that anyone in the world who criticized their regime essentially was committing some type of crime and could be held accountable by the Chinese government, which sounds absurd, but you know what? It also kind of rings true to me. I could see that being actually truthful. So
they're already basically practicing that. If you're a journalist and you visit China, they're arresting a lot of people and claiming they're spies and this, that, and the other. So you got to be really careful now if you're taking a trip there. If you're a guy like me who's been on YouTube talking smack about them, I don't think I got an invite there. I've got a nice, sweet lady who's invited me to come there and stay.
Don't go, Greg. Don't go. That's the old honeypot. You're going to get trapped. So don't do it.
Well, she made that invitation before she might have gotten motivated with a bribe. You can't get them here, but now
I see.
There can be extra incentive now. Yeah, Greg, come on over. Greg, go bye.
Yeah.
Nah. Hey, you know what? It's a beautiful country. It's got a lot of beautiful people there. I would love to go, but I'm not going to do it with things as they are right now.
Sure.
So, they're having a lot of difficulties. The floods they're having with the Yangtze River, the pressure on the three Gorges dams has me very concerned. The loss of food that they're going to have because of all the flooding. The Yangtze River Valley produces like 70%, I think. Oh, it's 40% of the grain, 40%. It's got 30% of the population. It's got 40% of the affluence. So that valley is very crucial to that country. So 400 million people. That's more than the United States of America that are right now being subjected to all these flooding. And it's a terrible thing. And it could get worse, though. Right now, it's a crisis. It could become a catastrophe if that dam ever let go. And I would submit that the water may not have to top over it to make it break loose. There's a lot of hydrostatic pressure behind it if it's not built to standard. And they had apparently one company that did the design, construction, and quality assurance also. You should really, really, really wonder. So, and there's, pictures that claim to show it deforming. These are things to be concerned about because, China right now might feel the urge to wag the dog to redirect the attention of the people to an exterior force. I say China, I'm talking about the powers that run the country, the CCP. Again, I'm not picking on the people. The people there are under quite a hardship right now. So I would say we should pray for them. You know, that's my take on it. You know, the people there, they're good people. They just, you know, they live under the jackboot. Anyway, that's my take on it. That's what I think. Now, a lot of people won't agree with that. But so we've covered a wide spectrum here. We're almost to the hour here, like in about 6 minutes, I think. So what would you like to say in closing that people ought to have in mind, bear in mind, to protect themselves from an EMP? You know, or what would you like to direct them to in your channel? That's
Sure.
what you want to say.
Yeah. So, I mean, you know, it's easy to talk about all the technical details of an EMP, and we can go down those questions over and over and get all the details right. But people need to start at a high level and really ask themselves what it is they're worried about. Not just an EMP, but you know, could be a weather events, or it could be a nuclear war, or it could be anything, right? I mean, there's lots and lots of threats out there to our safety and well-being. And so I always tell people to start by sitting down and figuring out what it is they're really worried about. And your worries are different than mine, Greg. We all have different worries. Once you figure out what you're worried about, make your list up, figure out what it's going to do to you if that thing happens, right? In the case of an EMP, we can run down what we're going to lose electrical power, then the dominoes are going to start falling, right? And then we can't get our food, we can't get our money, whatever those things are. And identify the impacts of that threat. Do that for each of the major threats that you're worried about. And then once you know the impacts of them, sit down and figure out, well, how do I protect my family from that impact, right? Maybe I can't get any food for 6 months or something like that. Well, obviously we could store food, or we could grow food, or we could do other things. And that sort of 3-step process is what I always tell people. Figure out, you know, what it is you're worried about, what are the impacts, and then what it is you can do to address those impacts. EMP is just one threat. It's what we call a high impact, low frequency event, right? It doesn't happen very often, but if it does, it's a big deal. And you need to think about all of the other types of things that might affect you as well, and kind of follow that process when you put together an effective preparedness plan. I talk about that in my handbook, and it's really the method I live by. I try and sort of work through that process when I'm worried about things.
Very good. And for everyone to know, Dr. Arthur Bradley is more than just a electrical engineer. He is a prepper too.
Mm-hmm.
And so I find that very interesting. He covers a lot of prepper ground. And so there's a lot of topics we could have Dr. Bradley back on here for. So I'd definitely love to get you back on the channel and
Sure.
talk to you again in the months ahead. Hopefully we do have months ahead that have the leisure to do this. The world today, who knows? It's crazy out there. really getting crazy. But you know, I really push. You know this. I push to actually get the grid hardened. I'm pushing for solutions. Mm-hmm. I do that because I think there's still hope. As long as we got hope, we need to work it. I see we could get an EMP from a nuclear event or several other things, and one of them is eventually the sun will get us if we don't do anything. So there's no excuse not to harden the grid, except the power companies just don't want to do it. And you know, the power companies have the National Electric Reliability Corporation that they all work through, that is their go-to house that covers them and is set up to write and propose the legislation to the Federal Energy Regulatory Commission, which is a strange, incestuous relationship they have between them. But so it's FERC and NERC, and FERC just rubber stamps whatever NERC writes, and that's really a bad situation. We've got to find ways to get what we need done. So I'll tell my people to write their congressmen. Laws have already been passed. There's things on the books. We just got to get it enforced. We got to get through the bureaucracy, make the bureaucracy and the deep state do the job that they're legally required to do. So you can also go to your Public Services Commission and go to your EMA directors in your state. You can probably recall meeting at my last conference that you came to, Ambassador Hank Cooper. And he actually did a lot of stuff himself, and he's got the big energy company hardening their grid because he went in and got them to realize through an exercise where the cavalry wasn't coming, what they'd have to do. These are things that the listeners to this video can get engaged in. So I'll put some links below this video for that. I'll put the links to your channel. So there's things everyone can do. And so that we'll know that everybody is watched at this point, you know, just a little tip, everybody say, hey, I'm really thinking about getting some conductive tape or a seal to go on my Faraday cage. And we all know you watched it to this point. So I like to leave a little tip in my video. Some of my videos I put pictures in, and I put a quiz about what are the pictures. That's a good little way to get people interested. It becomes a game, and my viewers tend to like that. So they get a kick out of that. It's important to engage with your subscribers as much as you can. And you've got your own YouTube channel, and you're doing real well at it. So I appreciate everything you're doing. I appreciate that, I look at you as one of the heroes, because you're out there trying to teach people what to do to protect themselves. And that really matters. It means a lot. You don't tell how many people that you're saving for whatever future event may come. So you're a hero. I appreciate it. And thank you for coming to my conference a couple of years ago and being on here now. And I look forward to seeing you again.
All right. Thank you very much, Greg.
All right, everyone. So please check out his channel, subscribe. If you're not subscribed to this channel, subscribe to it. Bang the update notification bell. Click all on both channels. And check my links below to support my channel. So everyone, have a great day. Thank you for watching. Bye. And I'm going to